We're integrating inverse trig functions today. Yay! Three of your most favorite things, integration and trig and inverse functions all in one. All right, so in Calc 1, basically what we're going to see is we're just going to see arcsine and arctangent as far as integrals. Those are the two forms we're going to recognize. We're not going to do any others right now. So let's remember that the derivative of arcsine is u prime, because of the chain rule, we have u prime over 1 minus u squared, right? And the derivative of arctan is u prime over 1 plus u squared. And again, this u prime comes from the chain rule because the derivative of arctan of x is just 1 over 1 plus x squared. And so that if u is a function, then we need to use the chain rule. Now, what you might have already guessed is if we see something in this function, we can get it into arcsine of u, which is usually pretty easy if this is just like 1 minus u squared, but of course it's never going to be easy. That's not how we see them usually. So you'll see you're going to use u substitution. Right here in the yellow, there's some things you could memorize if you want. I feel like it's almost harder actually to do it this way than with u substitution. I prefer u substitution, but you can just memorize that if I see this, then it's arcsine of u over a plus c. Again, it doesn't usually come out quite that pretty. Usually you end up with something in front of arcsine. So you have to do some reverse chain rule stuff. But you're welcome to memorize these and do it that way if you'd like. And there's some videos in the on my website that show it that other way, but we're going to do it with u substitution. Okay, so first things first, we're going to warm up by differentiating. We're going to differentiate arcsine of x over 2. So this is a chain rule, right? The inside function is x over 2, the outside function is arcsine. So we take the derivative of the outside function, which is 1 over the square root of 1 minus u squared, you know, whatever the inside function is, and the inside function is x over 2 squared because we keep the inside function still intact. And then we multiply that by the derivative of the inside, which is just 1/2. So we end up with 1 over 2 times the square root of 1 minus x. You know what? I'm just going to rewrite that instead of, that's just x squared over 4, right? Because when I square x, I get x squared. When I square 2, I get 4. Okay, so the unfortunate thing is we don't often see them quite like this either. We see them even more simplified. So let's just keep simplifying until we can't simplify anymore. So we know that the square root of, or that 2 is the same as the square root of 4. So I could rewrite this as 1 over the square root of 4 times 1 minus x squared over 4, because, you know, when I have two square roots like that, I can combine them together, multiply inside. Okay, and so then once I have that, then I have 1 over the square root of 4 minus x squared, because, you know, 4 times that and 4 times that. Okay, so the derivative of this is this. So let's see if we can go the other way with u substitution. Here we are. We know what the derivative of this is going to be because we literally just saw it. But let's see if we can do it without, you know, because we usually aren't going to know. So just remember that the derivative of arcsine equals u prime over the square root of 1 minus u squared. Okay, so this is helpful because we want to get it into this exact form. We want to get it into this form where it's just u squared, nothing else. And then it's actually really, really, really easy to integrate. Okay, so right now we have 4 minus x squared, not 1 minus x squared. Okay, so that's a problem. So let's start by dividing everything by 4. Hang on, my pen doesn't want to work. Okay, there we go. 1 over the square root. Okay, so we're going to divide everything inside there by 4. So we pull a 4 outside, so we end up with 1 over, or 1 minus x squared over 4, because I just divided that by 4. Okay, now we're getting closer. So let's simplify. Let's pull that 4 out, and we have 1 over the square root of 4 is 2. And so I still have inside the square root 1 minus x squared over 4 dx. Okay, and now that's still not quite something squared, right? It's x squared over 4, but it's not like a whole quantity, like one whole thing squared. So I need a whole thing squared. So let's figure out how to rewrite that as one whole thing squared. I have no better words to use than that. I don't know, like a whole thing, a whole quantity. You know what I'm saying? Okay, so I'm going to pull this 1/2 all the way outside the integral just so that it's not so messy. 1 over the square root of 1 minus, now x squared over 4, if I want that to be some quantity squared, that would be x over 2 squared, right? So really, this is the same as x over 2 squared dx. Okay, so now I'm really close, right? I'm actually in this form. I'm in this form, and my u is x over 2, right? So let's do a u substitution. U, oops, wrong one. U equals x over 2. Therefore, du equals 1/2 dx. Therefore, dx equals 2 du. So I can substitute that back in, and I have 1/2 times the integral of 1 over 1 minus u squared times 2 du. The 2's and the 2 and the 1/2 cancel out. I end up with the integral of 1 over that u, and that is just, let's just go ahead and evaluate that. That's just arc sine of u, right? Arc sine, getting ahead of myself and I can't write and talk at the same time. Arc sine of u plus c, and we know what u was, right? We already figured out what u was. U was x over 2. Oh, I keep grabbing the highlighter instead, so you guys are ending up with highlighting. There we go. So we were able to just go back with u substitution. We were able to find that the integral of this is arc sine of x over 2. Let's do another one. Okay, so this one is not in the form of sine. This one looks more like a tangent problem. So let's remember that the derivative of tangent of arctan equals u prime over 1 plus u squared. So again, we want to get it into that form, into something that looks more like that. So how do we do that? Well, let's first start by dividing both by 4. Actually, no, by 25. 25. And then we have 4x squared over 25 plus 1. So we're getting closer, right? We're actually getting a lot closer because now we have the 1, right? Now we just have to figure out, this is some quantity squared. Okay, this is just any quantity. We don't know what it is yet. We need to figure out what that is. So what, when I square it, do I get 4x squared over 25? Well, if I squared 2x over 5, I would get 4x over 25, right? So this is the same as, let's bring that 25 out here, 1/25. That's dx over 2x over 5 squared plus 1. Okay, so now we are in this form, right? We have u as 2x over 5, and we can now do a u substitution. So u equals 2x over 5, therefore du equals 2/5 dx, therefore dx equals 5/2 du. Okay, so let's go ahead and substitute back in. And when we substitute back in, we have 1/25 equals du over u squared plus 1 times that 5/2, right? That came with the du. So let's bring that outside. So we have 5/2 times 1 over 25. That becomes 1, that becomes 5, and we get 1/10. So we have 1/10 times the integral of 1 over u squared plus 1 du. Okay, we are finally in this arctan form, right? 1 over 1 plus u squared. 1 over 1 plus u squared. Awesome. So we can just know that the integral of that equals 1 over 10 times arctan of u plus c. And what was u? Well, u was 2x plus 2x over 5, or 2/5 x. So we're going to then sub that back in. So we have 1/10 arctan of 2x over 5 plus c. Let's look at another one. Okay, so this one, is this arctan or is this arcsine? This is arctangent. And again, arctan is the format 1 over 1 plus u squared. That's what we want it to look like, okay? So to get that 3 to be a 1, let's divide by 3. So we end up with the integral. I'll do this in a different color. So, all right, the integral of 8 over 3 times 1 plus 4x squared over 3 dx. Okay, so now what do we need to square? What squared equals 4x squared over 3? So basically we got to go backwards, right? We got to take the square root of the top and the square root of the bottom to figure out what we squared to get there. So to get to the top, we squared 2x, right? 2x squared is 4x because 2 squared is 4 and x squared is x squared. Okay, what did we square to get to 3? Well, isn't it just the square root of 3, right? So if I took the square root of 3 and I squared it, I would get 3, right? So the idea is when you have this quantity, you literally can just go backwards. You can just take the square root of it and figure out what our quantity is squared. Okay, so now we can switch that. So we have 8/3. Let's bring that outside. 1 over 1 plus 2x over root 3 squared dx. So now we have it into this form, right? 1 over 1 plus u squared. And what is our u? Our u is 2x over root 3. So we're going to do a u substitution where u equals 2x over root 3. Therefore, du equals 2 over root 3 dx. Therefore, dx equals root 3 over 2 du. Okay, so now we're going to sub in. So we are going to come back down here and we're going to say, okay, so we have 8/3 times the integral of 1 over 1 plus u squared du times root 3 over 2. And let's just take that root 3 over 2 out here. Just take it outside since we know it's a constant. We don't need it. Now we're in the form of arctan, aren't we? This is the form of arctan, and the integral of this exact thing is just arctangent of u. So let's simplify this outside. We have 4 root 3 over 3. And what is the integral? What is the integral of this? Well, it's arctan u plus c. And what is u? Well, u was 2x over root 3. So we end up with, our final answer is 4 root 3 over 3 arctan of 2x over root 3 plus c. Bam. That's not that hard, right?